I will now go ahead and talk about mood disorders, and I will start from a proposition which relates to what we actually know most effective in antidepressant medications and in depression. What we know today, when there's been repeatedly validated, is that plasticity is related to mood. Actually, in depression we find neuronal death and reduced spines and dendrites, reduced plasticity in neurons. This is very common, for example, in dementia, where we have 40% depressive phenomenology. And antidepressant effect, we know today that the SSRI, the famous Prozac and other medications, are synaptogenetic. They increase synapses and spines and dendrites, and they are actually neuro and synaptogenesis, and they increase plasticity. So we can assume now, in general way, that plasticity is related to mood, meaning that we can have neuroplasticity, elevated neuroplasticity, increasing mood tone, and reduced plasticity causing depression. Now, how can that be developed further? First of all, we have to remember that mood is an emergent property. Thus, it needs to be related to global brain dynamics. And we know that the serotonin neurotransmitter is available in vast cortical regions. Thus, changes in synaptogenesis spread out in the cortex will be related to global plasticity changes and to global emergent properties as mood. We also know, like in the description of personality, that the brain plasticity always acts to reduce free energy to the changing environment. So we can now assume that if plasticity is reduced, the possibility to reduce free energy to adapt to the changing environment is also reduced. There is a hampered matching dynamics, in the sense that the plasticity is not elevated enough in order to make the brain adaptable to the occurring changes in the environment. So now we can develop this idea further and say an emergent property of depression is when plasticity is reduced to the extent that free energy is increased. And when free energy is reduced by increasing plasticity, for example, in antidepressant effect of SSRIs, then plasticity increases, free energy is reduced because of the capacity of the brain to adapt to the occurring changes in the environment, and then we will have elevated antidepressant effect. So now we can connect mood changes to free energy levels. Okay? This model is interesting because it can solve an old conflict or problem of trying to classify depression into reactive depression, depression resulting from stress, and endogenic depression, depression resulting from unknown causes. So we can say that anything that hampers plasticity, being metabolic, hormonal, or whatever, dementia, reduces plasticity, and the occurrences in the environment, which is dynamic, continue to change, but the plasticity is not enough in order to adapt to those normal changes, regular changes. So free energy will increase, and depression is the emergent property of such dynamics. Now let's take an effective plastic neural system, and let's assume that there is a stressful event. Stress is always related to an erratic big change in the environment. If you lose a relative, this is a big change in the environment that you were used to. This will be statistically a vast bias of the input coming from the environment. If you lose your job or any other stress, is always related to big changes in the statistical structure of the environment. And this requires adaptive increased plasticity in the brain, but because stress is always also very sudden, or could be sudden also, in this case the plasticity is not fast enough in order to adapt to these sudden erratic changes, so you get increase acute increase in free energy, and then you'll have an emergent property of depression. So this is how such a model can explain both reactive depression and endogenic depression. Now, anxiety accompanies typically many mental disturbances, depression and others. So I would say that anxiety would be probably an emergent property of instability of the system. Instability is a very general name. You can actually go further and hypothesize that it is instability in the sense of frustration of constraints. Constraints would be each unit in the network is constrained by the activity of all the units connected to it. And the value of each unit depends on these constraints from other units. But if there are big discrepancies, if there is a mismatch, a big mismatch between the values of each of these units among themselves, then an emergent property of such a condition would be anxiety. And when the system is unstable and there are big changes and erratic, unstable values of the units, then the constraints between these units will be mismatching and frustrated, and there will be an increase in the instability of the system with an emergent property of anxiety. So this can also explain why anxiety is typically related to any instability in the brain. Anxious experience was described in depression and also in psychosis and personality disorders, and actually in many phenomenological aspects of mental disorders. So now we can see that mood and anxiety could be attributed to free energy instability of the system as emergent properties. So we can begin and substitute terminology like anxiety, which is not related to the brain, and use free energy mismatch and the optimization of free energy dynamics as brain-related, neural network-related, or neural system-related terminology. Now we go further and let's talk about psychosis and schizophrenia spectrum. Now, as mentioned in the first video, maybe where we have the most literature is the relation of psychosis to disconnection dynamics. We said that we have an optimal brain organization as a small world network organization, and this small world network organization can be disturbed by reducing the connectivity or disconnection dynamics, where you have different brain systems acting statistically independent. And as was given in the example, for example, you can have the auditory and speech system acting independently of the other systems in the brain, for example, the visual one, and then you'll have a fragmented experience of hearing people talking to your voices, and there is no one around when you look around. And also, if you have activations which are unrelated to each other, then if we assume that concepts and ideas are related to brain activations, and those become statistically independent, then we'll have loosening of associations. Associations are not related to each other anymore, like was when connectivity was established. So psychosis being fragmented experience with hallucinations and with loosening of associations and disturbance of logic, which is also related to associations, could be explained as dynamic spread in the brain of disconnection dynamics. Now, if we have disconnection dynamics, then we probably can have also the opposite. We can also have overconnection dynamics. There is much less literature about that, but at least our experience with neural network models, mathematical models, we understand that if you have increased connectivity, then units constrain each other to the extent that the system freezes like a crystal, or at least the system becomes limited in the number of activations that it can achieve, limited in the number of activations in the sense that they repeated themselves again and again. And this kind of reduction, phenomenologically, metaphorically at least, resembles negative symptom schizophrenia in the sense that you have reduction of thought process, poverty of speech, and perseverations in the sense that there are activations of the same ideas over and over again. So hyperconnectivity will cause the same neurons to activate themselves over and over again and have these repeated activities which translate into repeated ideation and repeated speech of perseveration. Now remember that in the first part we talked about the brain as a hierarchy. Now when you have hierarchy, you have higher level functions, processors, and lower level. And actually in the brain we know that we have top-down and bottom-up processes which are pretty much balanced. You have information traveling up the hierarchy, changing the higher level schemata and ideation, and you have the higher level internal representations or perceptions which could bias the incoming or could control the incoming information, like cognitive control. We know this for many examples. We have these sets of illusions illusions are actually when the brain biases the information that comes from perception. But if we assume that there is a balance between top-down and bottom-up processes, then we can predict that maybe we could also have disturbances of that balance. For example, if we have a bottom-up insufficiency in the sense that lower-level organization cannot achieve higher-level organization, then we can have a reduction in those emergent properties which are related to higher-level organization. For example, Marcel Mishulam talked about motivation being a higher-level emergent property when all the motoric system acts upon all the sensation system. So we have translation from sensation to cognition, as his paper is declared, and you have motivation emerging as a higher-level hierarchical property. So if we have insufficiency in that level, if we have bottom-up insufficiency, then we might lose this higher-level property of volition, which is very typical to negative schizophrenia patients. We can also have the opposite, where you have higher-level schemata biasing the incoming information. For example, you have an ideation or an idea about something in the environment, and everything that comes into your experience, everything that you experience at that moment will be biased to fit with that ideation. If that ideation is biased and incorrect, then you have a phenomenological description of a systemized delusion. In systemized delusion, you interpret in a biased manner, incorrect manner, everything that is happening, occurring to you in the environment. So now you can see that we can begin and take descriptions, phenomenological terminology of personality disorder, mood disorders, and psychosis and schizophrenia, and try to begin and relate them to different brain disturbances, being internal representation disturbances of small world network parameters in the default mode network for personality, disturbance of optimization dynamics in the sense of free energy reduction for mood and anxiety disorders, and disturbances of connectivity and hierarchical balance for schizophrenia spectrum.